Hello and welcome back. Now, in the last video, we implemented jumping and we saw that as soon as we hit the space bar, our rectangle flew up into the air and never came back down. And that's because, as far as our game is concerned, gravity does not exist yet. So in this video, we're going to learn about gravity and how we can implement gravity to make our objects fall back down. In order to understand gravity, we're going to talk about acceleration and how acceleration is really just a change in our velocity. So let's go ahead and get started. So what is gravity? Well, here's Scarfy, and let's just say he's in free fall. Now, gravity is pulling him downward with a constant force. So gravity can be thought of as a downward force, pulling all objects toward the ground. Now, when an object is in free fall, gravity is imparting an acceleration on that object. So in order to understand gravity, we need to understand what acceleration is. Now, you may have heard of Newton's famous second law, which says that force equals mass times acceleration. So we know that this downward force of gravity is related to the object's mass and an acceleration. So let's talk about acceleration. Well, we saw that velocity is a change in position over time. Well, acceleration is just a change in velocity over time. In the real world, all objects accelerate toward the ground at 9.8 meters per second per second. This means that your downward velocity towards the Earth is increasing every second by 9.8 meters per second. So here's Scarfy in free fall again. And let's just say that Scarfy begins at a position of 0 and that downward is the positive y direction. So as Scarfy falls down, his y coordinate is going to increase. Now, I just said that gravity is 9.8, but we're going to round it up to 10 just to make our math easier. So if the time is 0 seconds, Scarfy has just started falling, his velocity is 0 and his y position is also 0. 1 second later, however, because the velocity is changing by 10 meters per second, the acceleration due to gravity has increased velocity by 10 meters per second. Now, since the velocity is 10, when we update Scarfy's location, his y position is now 10, because at 10 meters per second, 1 second has passed, so his y position is now 10. 1 second later, we're at a time of 2 seconds. Now the velocity is increasing by 10 meters per second. So another second has passed and the acceleration due to gravity has increased the velocity to 20. Now with a velocity of 20, when we update Scarfy's location, we're going to add 20 to the y position, meaning that Scarfy now has a y position of 30. 1 second later, we're at 3 seconds total, and velocity gets another 10 added onto it due to this constant acceleration of 10. Now, since another second has passed, at a velocity of 30, we now have to add 30 to Scarfy's y position. So he's now at a y position of 60. So as you can see, every second, Scarfy's velocity is increasing, which means he's falling at a faster and faster rate. This is why it's so dangerous to fall from a high position, because as you fall toward the ground, your velocity keeps increasing. 1 second later, we're at 4 seconds, which means the velocity gets another 10 added to it, and when we update Scarfy's y position, we're adding 40, so his position is now 100. So Scarfy has fallen off of this graph. Now, how do we update the velocity? Well, here's our while loop, which gets executed every frame. And every frame, we're updating the y position by adding the velocity to it. Well, let's say we have a gravity value of 1 pixel per frame. So every frame, velocity increases by 1. Well, to update the velocity, we simply have to add the acceleration due to gravity to the velocity every frame. So before we update the y position, we update the velocity by adding the acceleration due to gravity. Then we can update the position by adding the velocity. So let's see how this works in our program. So here is our dasher.cpp, and here we're updating our location. I'm just going to comment this with update position. Now, if we're going to have an acceleration due to gravity, we're going to want a variable for that. So let's go up here, just under init window, and let's create a const int, since we're not going to change this value, and we'll call this gravity. I'm going to initialize this with a value of 1, and I'm going to comment it acceleration due to gravity. And I'm also going to put pixels per frame per frame. So every frame, the velocity is going to change by this many pixels per frame. So before we update the position, I'm going to apply gravity. Now, how are we going to apply gravity? We're going to take the velocity and add the acceleration due to gravity, which we called gravity. So now every single frame, velocity gets 1 added onto it. Now we may be subtracting 10 from our velocity whenever we press the space key, and that's going to make our object jump. But gravity is constantly pulling velocity downward. So let's go ahead and hit run and start debugging. And there goes our rectangle. We saw that it just started to fall and went straight through the floor. So that's an issue, right? We need to figure out if we're on the ground and somehow stop gravity because the ground is pressing us back up. So let's think about how we can apply gravity only if we're not on the ground. Now, I'm going to create an if check. So right here above apply gravity, let's say if, and in this if check, we can check to see if we're on the ground. Now, we need to take our y position, pause y, and see if that is greater than or equal to a certain amount. Now, if our rectangle is on the ground, and the rectangle's y position is the y coordinate of its upper left corner, then what exactly does pos y need to be equal to or greater than for us to consider the rectangle to be on the ground? And you probably guessed it, it's going to be the location of the bottom of the window, which would be window height, minus the height of the actual rectangle, which we called height. So we have an if check here, and I'm going to give this a comment and say ground check. And if pos y is greater than or equal to window height minus our rectangle's height, then we know our rectangle is on the ground. And if that's the case, then we can simply set our velocity back to 0. And we can have an else case here. Now, if we reach this else body, that means that this condition was not true, so we failed the first if check. If that's the case, then we know that rectangle is in the air. And if the rectangle is in the air, then we can apply gravity. So we can go ahead and take this velocity plus equals gravity and move that into the else case here. So we no longer need to apply gravity right there. Now, when we press the space key, we want velocity to have 10 subtracted from it, and we can't set velocity equal to 0 after we subtract 10 from it because then we'll never jump. Velocity will always be 0 if we're on the ground. So we need to do this space key check after the ground check. So let's copy this and delete it and move it down below the if else right here. And just so we understand what it is we're doing here, we're going to say check for jumping. So we perform the ground check first, and if we're on the ground, our velocity will be 0. But if we're in the air, we're going to subtract from velocity the amount equal to our gravity acceleration. And after all that, then we check to see if we're jumping and update our velocity due to jumping. So let's go ahead and run and start debugging and see how this works. Okay, so we're sitting on the ground. If I hit the space key, then I jump. Now that's a pretty weak jump, so we may want our jump velocity to be a larger value. And I can go ahead and instead of hard coding 10, We can make a const int here called jump vel for jump velocity. And why don't we initialize this to something like -22? I'd like to use a negative value here since the upward direction is the negative direction. And that way, when we update our velocity down here, we can simply add with plus equals, and we can add jump vel. So we're adding a negative value. Let's go ahead and test this out now. And now we're jumping a little bit higher. So we can tweak that jump velocity if we want to jump higher or lower. Now, there's something I want you to notice. If we jump while we're in the air, we get this sort of double jump. And that's because we have no check to see if we're in the air before we apply that jump velocity. So here's your challenge. I want you to prevent air jumping. Create a Boolean called isInAir. And you're going to want to set this value in our ground check. So if the rectangle is in the air, set this Boolean to true, and if the rectangle is on the ground, set this Boolean to false. Next, you're going to only jump if isInAir is false. So if isInAir is true, then pressing the space key should do nothing. Go ahead and pause the video now and try to implement this. Okay, we're back in Dasher.cpp, and we need a Boolean for whether or not we're in the air. So let's go up here, and I'm going to place this just above the rectangle dimensions, and I'll make a Boolean called isInAir. I'll use braced initialization, and that way this will be initialized to false by default. Now we can go down here and update isInAir in our ground check. Now, we know that if pos y is greater than or equal to window height minus height, then the rectangle is on the ground, which means we can set isInAir equal to false. And in the else case, we know the rectangle is in the air, so here we can set it to true. So after our ground check, isInAir will now have the correct value. So here we're checking for jumping. Is key pressed will determine whether or not we should change velocity according to our jump velocity. Well, we can use an AND here, and we only want to jump if we're not in the air, which means isInAir should be false. Well, we can use the negation operator and say not isInAir. When we apply the negation operator to isInAir, we can read this as not isInAir. So this if check will only succeed if is key pressed is true and not isInAir is true. So let's go ahead and hit run and start debugging and see how this works. So I'm jumping and pressing the space key while I'm in the air, and nothing happens. So I'm only able to jump once I've hit the ground, no more air jumping. Okay, so in summary, we've learned about gravity, and we've learned that gravity applies an acceleration on all objects that are falling towards the ground. We learned that acceleration is a change in velocity, and we learned how to apply gravity to our velocity each frame. We also implemented a ground check so that we can only update the velocity if we haven't yet hit the ground. We also added a Boolean called isInAir that's true when the rectangle is in the air and false when it's on the ground. We then use this Boolean as part of the condition for jumping so that we can only jump when we're not in the air. So now we have jumping and gravity implemented for our game. In the next video, we're going to work on actually drawing a two-dimensional character so that we don't have to look at rectangles anymore. We can actually look at something that looks a little bit more visually pleasing. Okay, I'll see you in the next video.